Hello everyone, I'm Tarun Prajit from CAC graduating in SPCU. Let's see about user-based and item-based similarity in recommender systems in this presentation. Welcome today. We will dive into the fascinating world of recommender systems, focusing on two fundamental approaches, user-based similarity and item-based similarity. These methods are crucial for predicting user preference and suggesting relevant items, driving the success of online platforms like Amazon, Netflix, and Flipkart. In this slide, let's see about the introduction to similarity metrics. Understanding similarity. Similarity metrics are the backbone of recommender systems. They they quantify the degree to which user or items are alike. We will explore how these metrics are used to predict user preferences and make personalized recommendations. The next one is types of similarity. There are two similar approaches: user-based similarity, which focuses on users' past interactions, and item-based similarity, which consider how items are related. We will delve We will dive into advantages and limitations of each. In this slide, let's see about user-based similarity. The first one is identifying similar users. This method finds users with similar tastes based on their past interaction with items. For example, users who rated the same movies highly are likely to have similar preferences. Second one is predicting preferences. By analyzing the ratings of similar users, we can predict the likelihood of a target user liking an item. For example, if a user rated a specific movie highly and similar user also rated it well, it's likely the target user will enjoy it. Recommendation generation. User-based similarity enables us to recommend items that similar users have enjoyed. Target users use certain devices which will help us discover new recommendations. In this slide, let's see the limitations of user-based similarity. Sparsity. User-based similarity often faces data sparsity, where there are few users with sufficient overlap in their ratings. This can make it difficult to find sufficiently similar users to make accurate predictions. Next one is scalability. Finding similar users can be computationally expensive, especially for large datasets with millions of users and items. This can become a bottleneck in real-time recommendation systems. The third one is cold start. User-based similarity struggles with cold start problems, where new users learn history to establish similarity with existing users. This can hinder initial recommendations. In this slide, let's see about item-based similarity. First one is analyzing item relationship. Instead of focusing on user in similarities, item-based similarity examines how items are related to each other based on user ratings. For example, movies often categorized as action are likely to be similar. Predicting user preferences. Item-based similarity predicts user preferences by considering items that the user has already interacted with. If a user likes item A and item B is similar to item A, then it's likely that the user will also enjoy item B. The third is recommending similar items. Item-based similarities recommended items similar to interacted with, expanding the exploration within, often used to suggest you might also like recommendations. Advantages of item-based similarity. Scalability. Item-based similarity is more scalable than the user-based similarity because it is only needs to calculate similarity between items, which is often a smaller set than the number of users. Next one is efficiency. Calculating item similarities is typically faster and requires less computational power than the user-based similarity, making it suitable for real-time recommendation systems with large datasets. Third one is cold start mitigation. Item-based similarity can mitigate cold start problems by recommending similar items even for new users who haven't yet interacted with many items. This helps us provide relevant recommendations from the start. In this slide, let's see the limitations of item-based similarity. Limited context. Item-based similarity doesn't fully account for user preferences and context. It simply recommends similar items based on past interactions without considering the user's specific needs or interest. Over-specialization. Item-based similarity can over-specialize recommendations by only suggesting similar items, potentially limiting the user's exposure to new and potentially more interesting items. Lack of diversity. Recommendations based solely on the item's diversity, leading to repetitive suggestions cater to the user's evolving preference. In this slide, let's see about hybrid approaches. Combining strengths. Hybrid approaches combines the benefits of both user-based and item-based similarity. This addresses the limitations of each approach while leveraging their strengths to create more effective and personalized recommendations. User-based user-item collaborative filtering. One common hybrid technique is user-item collaborative filtering, which considers both user similarities and item similarities to predict user preferences and generate recommendations. Next one is content-based filtering. Another hybrid approach involves incorporating filtering, where item attributes and user profile understand the underlying content and prefer more informed recommendations. And we have come to the conclusion and key takeaways. Key approaches. User-based items and item-based similarities are two fundamental approaches and recommender systems, each with its own strengths and weakness. Hybrid power. Hybrid approaches combine the strengths of user-based and item-based similarity, leading to more accurate and personalized recommendations. Future of recommender systems. The future of recommender systems lies in innovative hybrid approaches and the use of advanced technologies like deep learning and artificial intelligence to provide more comprehensive and engaging experiences. Thank you.